So today we're speaking with Rich Depoto, Business Development Manager with Uyemura International Corporation in Southington, Connecticut. And today we're going to be talking with Rich about the Arguna platform, hard silver electrolyte for deposition of silver with giving a really good high hardness. Rich, thanks for joining us, and tell me a little bit about the background of this development of the Arguna platform.
Sure. First of all, thank you for speaking with me today. Really our favorite subject to talk about, specifically because of the growth of automotive electronics. That is the main driver. Silver has been long-standing as the metal of choice for the electronic designs and such. And with the advent of the electrical vehicles, all of the rules for automobiles have changed, and for silver. And so this Arguna platform is intended to address all of the new demands for existing and future electronic vehicles.
Right.
You know, things have changed. There are four areas that have really changed. Number one is that voltages have gone from 12 to 24 to 1,000 volts. Wow. So we're putting 1,000 volts through things. Secondly, temperatures, which were around 80 C max, and sometimes under the hood, which was easy to protect. In an electrical vehicle, many of the sealed components, powertrain, etc., all get to 150 degrees C, which is dramatic. Next is electromigration. Under those temperatures, and operating temperatures, silver, is susceptible to dendritic growth, shorting, things like that. And lastly is moisture. In some of the components and such, the more moisture could be tolerated, now it can't be tolerated at all. And so silver needs to change. It needs to be a silver on steroids. And so that platform plays to that metaphor. And so we've attacked it in a number of ways, which I'll be talking about today.
Right. And one thing I saw was that it has a much better wear resistance than typical silver layers, right? Conventional silver layers.
Yeah, initial silver has a hardness after heating, but even base of about 70 to 80 hardness. That it is not intended for those wear applications on connectors, number of insertions, etc. And so a harder silver was the first thing that we looked at in order to get the number of insertions, up. Originally, automotive thought they might need maybe 4,000 to 5,000 insertions. Today, they've changed that, and they're feeling like they would like to write a specification, which is at this point really impossible to meet, of upwards of 10,000 insertions. And so silver has to change. And one of the classic ways to do it is to make it harder. And so we've put together an entire platform of alloyed products in silver to be able to get a range from the existing 70 of pure silver all the way up to well over 200 hardness.
Wow.
And so,
one of the things I read about the Arguna platform, it really is good for application where you see a lot of mechanical stress, right? Where they're exposed to a lot of mechanical stress. This is a very good product to use in those type of applications.
Absolutely. Silver begins recrystallizing at a much lower temperature than people believe. And so we've got to raise that up. And the only way to raise it up and make it more reliable is to alloy it with things like antimony, bismuth, copper. We have a copper product. And we've also alloyed it with the precious metal palladium. And that's the one that actually achieved over a 200 hardness even after heating. So it's a high temperature, hard silver, really an advanced material for really some of these real critical applications.
Right. It's funny you mentioned before about with automotive and how it's truly changing at a very fast pace, right? As these developments are coming along with EV. Talk about that a little bit. I mean, you all have been in very close contact with a lot of the automotive manufacturers about what they want, what they're going to ask for. And it's really, a tribute to your R&D that you guys are really trying to keep up with this as quickly as possible. But it is moving pretty fast, isn't it?
Yeah, and that's different than history. When we say the internal combustion engine was a high percentage of mechanical parts, truthfully, things changed slowly because mechanical parts were difficult to test reliability, and things moved relatively slowly compared to today. Today, the demand is for quick implementation. They're much better at telling whether something's going to work or not due to advanced testing techniques. And so when they see daylight and when they see something that can really address a problem, we find the automotive industry moving at a rapid rate, which is great for us. And yet at the same time, we've got to be, it's more important that we're ahead of them and that we got the data to support and we're able to answer and anticipate all the key questions,
Right. Yeah.
And so that's what we think we've put together here. We think that this platform is more comprehensive than any one that we benchmarked against, and we're really looking forward, to get the message out there on its capabilities and getting things tested and looked at.
Talk about the applicator. What will they see out of this Argon platform? What's going to be the benefits that they're going to get, in the usability of this product when they apply it for their customers?
So they're looking for, as I said, that high power. They're looking for the high temperature and those numbers of insertions. And so right off the bat, we went after increasing the hardness and the mating. It got a little complicated because once there still will be a fair amount of base pure silver in the system. So not only does the hardness have to be good when a connector is built for itself in terms of insertions, it also needs to work when mated with the standard silver. So we've worked very closely with a number of the electronic automotive guys to test that and make that work. They have also asked us to expand the platform from alloys into what's called dispersions. So dispersions have been in the industry for a long time. Now, different than an alloy, this is sort of a matrix of silver and other materials. Could be such as Teflons or graphites or things like that can afford the kind of lubricity that a connector would really like to see. And so the platform is expanding. It has actually included something called sealants in addition, silver tarnishes. So the need to protect that surface and not have oxidation and discoloration. And so we've developed an entire Arguna sealant series, which includes both organic and inorganic sealants to actually protect silver as well.
Correct.
So very broad-based, comprehensive approach to make silver do things that it in its virgin state, is not really possible.
Right. Is a lot of this application just for the automotive industry, or are there other industries that could possibly use this?
Definitely spill over. The key to this and the key to the entire platform, it is very cost driven. Always when they set the goals out, there's not a lot of room to increase cost in any way. So the other industries will be happy about that. All right.
Right.
That they'll actually be able to upgrade and improve performance and still meet their cost targets. So I expect it to be, yes, very broad-based use. And it's also drop-in. That's always key. There's no additional equipment changes, really, modifications. It works with the existing processes and stuff.
Right. And so this platform you've got, with the Arguna platform, you've got different products, right, meeting different needs. You've got a variety. It sounds like you've got a variety of
really a series of more than 10 products, 10 alloys, as well as 2 dispersions that are commercially available, as well as 3 sealants. So that's the entire platform as it is today, with more new products expected later on in the year as we get more familiar with the requirements. Because they're constantly upgrading them. So. Yeah. That's why we got to stay close. We're members of not only a number of joint programs with the automotive designers and such, but also the consortiums, which are trying to steer things from the top.
That's great.
The last piece the other piece that they talk about is the sustainability piece. The word has moved from green, always important, right? Something we want to be part of, and then there's a practicality of the sustainability, and so the product line has also been able to remove cyanide from a number of products for sustainability, which is very unique for a silver product, because for forever, silver and cyanide was a great marriage with producing great properties. So there are 2 cyanide-free formulations for those that want to get ahead of things and move in that direction. So,
right. Yeah, I had a finisher ask me one time, what was cyanide doing there and what replaced it? This was on it was on cobalt. But what was cyanide doing in some of these products? And again, what did you put in to replace it, if you can talk about that?
Yeah, I can't give you the specifics on the replacement. So cyanide is a complexing agent and a stabilizer to the entire system. It kind of makes sure that the atomic release and the atomic stacking of silver occurs in a very controlled way.
Right.
So it's really the stabilizer and the controller chemical, in the system, and so removing it always resulted in really bad things, very dull finishes, very irregular, deposits and stuff, and so you know how hard it's been to replace it with gold. It's been the gold standard for cyanide as well. Same kind of mechanism.
Right.
And so the new stabilizers or complex organics that function like cyanide but are not cyanide based, and so that is increasing. If anyone who had the chance to remove cyanide, if they thought that they could get an equal product or close, everybody's interested in that. Everybody wants to consider that. So.
Great. Well, like you said, you mentioned sustainability, and I know that's very important for a lot of OEMs with that. They're pressured into that, and they are moving in that direction. So it's very, like I said, with this product line, it's very key that falls into that use and that need of what some of the OEMs are looking for as well. So definitely.
Yeah, I'm excited about the approach, because we really tried to take a holistic, look at it and try to look many years ahead for it to make sense. It does seem like companies are willing to invest the long term. That whole, we got to solve this one short term, and that, look, it's always present to pay attention to that. But I find that the companies are looking more in 5 and 10 years out, and making decisions based on that. So we've got to do it that way too. If we're going to be a long-term supplier, we're going to have our own sustainability. So.
Right. Well, listen, I appreciate you taking time out. It's you can go to Uyemura.com and look. I know you got lots of information on there about not only just the Arguna line, but some other lines that you have for other applications. But again, thank you very much for joining me, Rich.
If I can give you one more. We
Yeah,
were,
right ahead.
you know, that 10,000 insertions?
Insertions, right.
Yeah, using the dispersive strategy, we were able to attain that and remove
Oh, wow.
all of the lubricants from the system. So the system is a dispersion of silver. It's self-shedding, and we were able to obtain wear resistance for 10,000 insertions. And so that's a pretty unique product that I think has really the great potential.